Okay, pre-calculus pre-calculus students. We've already been through the lesson on factoring, and we've been through the initial lesson on completing the square. Some of the things that I wanted to touch on that were not specifically covered in the lesson were the differences between these two formulas, this version of the problem versus this version of the problem. And they both really are talking about two separate things. This, on the left side, is asking me to find where this graph crosses the x-axis, where its roots are. This, on this side, show me the graph. So the difference between putting it f of x equals and setting it equal to 0 are just really in deciding what it is that I'm trying to return to the person asking the question, for which most of the time it's me. All right, so we're going to talk first about why factoring won't work. Oh yeah, somebody else is talking. Why factoring here won't work. A times C is a positive 3, which means that I really only have two choices, and neither one of them are going to give me 8, so this thing is not factorable over the integers. But I suspect that since this particular graph has both arms up and it's got a y-intercept of only 3, I'm guessing that it's going to have some roots, some real roots. They're just going to be irrational numbers. But I'm not going to find them by factoring. It would be nice if I could, but it just won't work. So in this case, I'm going to work on completing the square to solve it, which is one of the things we worked on in class. I start by moving that 3 out of the way, and then I just have to figure out what should be here in order to finish it. So I'm going to take that negative 8, slice it in half, which gives me a negative 4, and I square it, get a 16. So I got to really do the same thing to the other side, otherwise it gets unbalanced. So the left side is really x minus 4 quantity squared. The right side is not a 15, but a 13. Now, since I'm really just trying to find what the actual roots are, I can take the square root of both sides. Of course, not forgetting the more than important plus or minus. And last but not least, I bring that 4 over to the other side. And then perhaps I should find the decimals, but I'm going to leave that for another task. Now, I want to go over here because this on the yellow side we haven't yet really covered. I want to show you what it would look like if I completed the square with the f of x there. There isn't any reason that I couldn't yank the minus 3 over to the other side. And that makes the left side f of x minus 3. And then I could figure out that I need to add that same exact 16 to both sides, just like I did in the other one. Over on the right now, I've got this x minus 4 quantity squared. On the left, I have, it seems a little weird, but it's not really any different than what we did when it was a 0. And my last step is going to be to move that 13 back to the other side. And I get x minus 4 quantity squared minus 13. And this is what it looks like when I do that in function mode as opposed to roots mode. Okay? It all depends on, did it come from f of x or did it come from equal 0? All right. Let's take a look at another one. So let's try, all right, and I'm just winging this right here. Whoops, let's do the 0 one over here. We'll keep everything consistent. How about 0 equals, I don't know, negative 2x squared plus 8x minus 7 versus the function version of it, f of x equals negative 2x squared plus 8x minus 7. Now, before I get too gung-ho on this, I'm mentally thinking through already what I know about this graph. The negative 2 tells me that it's opening down. I've got a y-intercept of negative 7, so I don't know whether it does this, or maybe it does this, or maybe that's the vertex and it does that, or maybe both of the roots are negative and it comes down through there. I'm not really sure what it's going to look like exactly, but it might have two roots, it might have one root, it might not have any. Since I just made this up, I have actually literally no idea what's going to happen. It'll be so exciting. All right, so I'm going to just start by adding the 7 to both sides so that I get a positive 7 over there. Um, I'm going to divide everything by a negative 2. Let's see, I think that's right. Yeah. So I've got that negative 2 out of the way, and I want to do that so that I don't have to deal with that negative 2 when I'm actually completing the square. So I'm going to have x squared minus 4x, and then over on this left side, it's, I don't know, negative 7 halves. You guys said you weren't happy about the fractions, but you can deal with it. Now I'm going to complete the square, so I'm going to add, let's see, I take this number and I slice it in half, negative 2, and I square it and I get plus 4. So I got to do that to the other side as well. Now when I go about completing the square, this right side is x minus 2 quantity squared equals, I think this comes out to be a positive 0.5. You can double check that. Now I take the square root of both sides, never ever forgetting the all important plus or minus there that allows me to get the two answers. And last but not least, I shove that 2 over to the other side. And whether I put it as a fraction or whether I put it as a decimal, either way, I've got two solutions. They're both real numbers. Neither one of them are imaginaries. I didn't get any negatives in square roots. So that means that it's definitely one of these taller parabolas up here because it does cross over twice. All right, let's take a look at what it would look like over on this right side. So this time I'm going to do the same sort of thing. I moved the 7 out of the way. I still don't want that negative 2 there, so I'm going to pull that out. Now this is the only spot we need to be just a little bit careful of, because when I divide both sides by negative 2, I have to divide the whole side by negative 2, not just the 7. So now I've got x squared plus 4x, and I didn't really leave any space there, so I'm going to move that over, because I need to add a plus 4 here and a plus 4 here. So on the right side, notice how closely this is matching what's happened over on this side. They're really almost exactly identical. The only difference is the f of x that is missing on the left. Okay, so I factored that into x plus 2 quantity squared. I still have all this, and it looks a little scary, but the good news is all I have to do is undo it. I don't have to do any other trickery to it. So I'm just going to slide that back over, and I'm left with f of x plus 7 over negative 2 equals x plus 2 quantity squared minus 4. So I move that 4 back to the other side. Now in order to get rid of that negative 2 on the divided by, I got to multiply by a negative 2. But I got to multiply everything by a negative 2. Do you care if I put it over in the front side? I'm used to seeing the numbers in the front. I think you are too. So I'm going to put it there instead. Well, these guys are going to cancel. I'm going to be left with f of x plus 7 equals a negative 2 times x plus 2 squared. I'm going to go ahead and put that all the way in, plus 8. Now I know that there's somebody out there, and I can think of a few of you by name, that are tempted to put this negative 2 all the way into that parentheses. Bad, don't do that. That parenthesis is squared first. You cannot shove it into a squared parenthesis. You'd have to FOIL that all out and then put it in, and we don't want to do that. So I'm going to subtract 7 and subtract 7, and now I am at f of x equals negative 2 x plus 2 squared plus 1. Yoo-hoo! And that is the completed square. Now you might be looking back over here and comparing these two answers, probably like right there, for instance, and saying, what? Those don't look like they're the same thing at all. Over here I got a half, and here I got a plain old x minus 2 quantity squared. Well, just so you don't think, oops, just don't think I'm making stuff up, I'm going to take that exact same thing. I'm going to do it in green, just so you believe me. zero point 0.5 equals x minus 2 quantity squared. Well, I know that 0.5 is equal to a half. So would you agree I could multiply both sides by a 2? Yes, Mr. Hampton, I do. Okay, so I can multiply both sides by a 2, and I get 1 equals 2 times x minus 2 quantity squared. And then, uh-oh, I lost a negative someplace, didn't I? No, I didn't. I'm okay. So I subtract 1, and I get 0 equals 2, x minus 2 quantity squared minus 1. But wait, you say, these aren't the same thing. I mean, look, right? Here versus here. Well, the signs are exactly opposite. So if I multiplied everything by negative 1, I would get negative 2, x minus 2 quantity squared, plus 1. Same thing. All right? I don't really need to do all that work. I was just showing you that it did work so that you would believe me. I mean, you do believe me, right? All right, so here we are. We're going to continue on. New problem. This time I'm going to be a little more adventurous here, and I'm going to do it with a odd numbered fraction. So I'm going to go like this. I'm going to go f of x equals, let's go with 2x squared plus, I'll go 5x minus 7. Oh, that's enough odds that I'm going to probably really have to work hard at this, but that's okay. Now, if all I'm trying to do is find the roots, I would put a 0 here and start the process. But since I'm wanting to show you guys what appears to be the harder, okay, stop it. What appears to look harder was when you leave the f of x there. I'm going to start with this, completing the square this way. So first I started by moving that 7 over. Then I divide that 2 out, and here I'm going to get a fraction. Ugh, but that's okay. We'll just live with it. I got to divide both sides by 2. Or would you be okay if I multiplied by a half? Could you live with that? It's the same thing as multiplying by 2. I'm dividing by 2. So now over on the left side, I'm just going to leave it like this. F of x plus 7. I don't want to multiply all that in. It's too much work. And on the right side, I got x squared plus 5 halves x. All right, speaking of work, now I actually have to think, because I got to take this 5 halves and I have to slice it in half, which means multiply it by a half. That gives me 5/4, and then I got to square that monstrosity, which is 25/16. And I know some of you are like, oh, we don't like the squares, it's fine. Whatever, you just have to deal with it. So I add 25/16 over there. If you want to do this on your own with decimals, you can do it with decimals. But I'm going to leave it this way for now. Okay, so my completed square looks like this, which incidentally is this number right there. And over on this left side, I've got 1/2 f of x plus 7 plus 25/16. I know it looks messy on the left side, but we're going to just reverse all this stuff. I'm going to move this guy over, the 25/16. So now I have 1/2 f of x plus 7 equals x plus 5/4 quantity squared. Let's say I got to subtract 25/16. All right, being very careful as I go. Now I got to undo this multiplied 2. So I multiply both sides by a 2. Make sure that I multiply everything by the 2 in there. I can't just pick and choose. So the left side now has become f of x plus 7. And I've got 2 times that stuff. And I actually already know this, but I'm going to show you so that you don't think, uh-oh, so you don't think I'm making stuff up. 25/16 times 2. 25/8. You did believe me that I knew what the answer was, right? Now I got to subtract 7. Ugh. Okay. I don't think I know the answer to that one. But that's why I bought a calculator. Or in this case, the school did. So I've got negative 25/8 minus 7. Pow. Negative 81/8. So according to this, if you're one of those people that really like the decimal versions, no, I didn't want it decimal. I wanted that as a fraction. Negative 10.125. Okay, so this is what I've got for my completed square form. So I just wanted you to see that it could be done with harder looking problems. It's not tons and tons of fun, but it is a moment of success when you have gotten there. There are some things that I can tell about the graph. First of all, from here, it opens up. Both arms are up. It has actually been vertically stretched by a factor of 2. 2. I can also tell from here that the vertex is at negative 1.25, comma, negative 10.125. A couple of numbers that only their mother could love. And back from the original problem, I knew that the y-intercept was 0, comma, negative 7. So even though I don't really want to draw these numbers out, I could, and I'd have a pretty accurate graph of what this thing looked like. And it wouldn't be hard to figure out what the roots are of this thing just by putting a 0 right here and working it out from there. I'm going to ask you to take a look at the Moodle website for our class, and in the Chapter 2 stuff right here, you'll of course see some videos that might help you, which is actually probably where this video is sitting. And then there's some of these mandatory homework things. Now you do get multiple attempts to try them. I'm not sure about this 10 question one. I don't know if I'm going to have you do that just yet. Start with these two. Start with these top two. Complete the square and solve, factoring and solving. All right, practice your completing the square skills. You should have assignments 2A through 2C all done. Okay? All right, that's where I'm going to sign out.